So concurrent, they are concurrent forces. Forces that act on a body or a particle at the same time. So this is scenario 1. Scenario 2, the same body, the same mass, of 50 kilogram. This time around, the two forces act oppositely to one another on the body. So we have F1, then we have F2. F2 S2, the same forces, magnitude of forces, but they act at different angles. This is F1, 100 Newton. They act oppositely to one another. Then scenario 3. $50 kilogram, the same mass. This time around, the forces act. Jaden. Hello, Jaden.
Yes, sir.
Whatever you are saying is being delivered to me.
Okay, sir.
So we have F1, which is 100 Newton, acting due west. Due east. And then Franca, can you mute yourself? Then F2, which is 250 Newton. This time around, the angle between the forces, the two forces, is 90 degrees, meaning the two forces, F1 and F2, act perpendicularly to one another. So these are the 3 scenarios. Now the main question. Calculate the acceleration. Calculate the forces or the two situations that will produce the greatest acceleration and then the least acceleration. Calculate 1. The greatest or the largest acceleration produced by the forces. And determine the direction. So you are calculating the greatest or the largest acceleration that will be produced by the forces and the direction of the acceleration. And then 2. Okay, let me leave it at at 1. So we have two scenarios, two forces acting concurrently on a body, meaning they are concurrent forces, and concurrent forces act at the same point, at the same time on a body or on a particle. So F1, F2 are two parallel forces in the scenario 1. Scenario 2, F1, F2 act oppositely to one another on the same mass, 50 kilogram. Caro,
I'm coming.
Caro, mute yourself.
Yeah.
And in the third scenario, the two forces act perpendicularly to one another on the mass. We are to calculate, or more or less, we have to calculate the acceleration and the direction of the acceleration, or determine which one of these three cases will produce the greatest acceleration, and then the direction of the. So the question can be determine which of these three forces would produce the greatest acceleration. Start work. Let me give you about 6 minutes for this work. It's 1:40. Start work. So I have reconstructed the question. So which of these forces would produce the greatest acceleration on the mass? And then the second question is that determine the magnitude of this acceleration and the direction. I think this is more precise than which of these forces would produce the greatest acceleration. Then determine the magnitude of the acceleration and the direction. So class, quickly make me proud. It's an application of what we went through yesterday.
Sir, please, can you repeat the last part?
So the question is that which of these forces would produce the greatest acceleration on the mass, and determine the magnitude of this acceleration and the direction. Determine the magnitude of this acceleration and the direction. You have 5 minutes more. Francis?
Yes, sir.
Your hand is up. Have you finished?
I said the answers.
Okay, don't worry. We'll
Yes,
discuss
sir.
it. So when you finish, keep it. We'll discuss, okay?
Okay, sir.
Recording in progress.
You have 3 minutes more. 3 minutes. Which of these forces would produce the greatest acceleration on the mass? And then determine the magnitude of this acceleration. You have 2 minutes to end this work. Two minutes. Okay. I'm sure you've all finished. Is that correct? Have you all finished? Class, have we finished? Okay. Being quiet means yes. So, which of these three forces would produce the greatest acceleration? Anybody? Will it be 1, 2, or 3? Francis?
Sir, to be the first one.
Pascaline?
You said the first one.
Why? Why must it be the first one? Pascaline? Okay. Jedediah wants to also come in. Jedediah Odonko. Do you also agree with them that it will be the first one?
Yes, sir.
Can you explain?
The first one will produce the largest acceleration amongst all the three.
Why? Jedediah, why? Francis, why?
Sir, amongst the three, the first one produced the highest acceleration with the value of 7.0 meters per second.
Why?
Sir, because its resultant force was high as compared to the others.
Exactly. Acceleration is directly proportional to the applied force or the resultant force. Okay, so if when you calculated, you had the largest resultant force, then automatically it must be equal to the one with the largest acceleration. So let's determine the total force. Let's calculate for the resultant force. When two forces are acting along the same direction, how do we determine the resultant force? Let the ladies also come in. They seems to be so quiet. When two forces are acting along the same direction, how do we determine the resultant force or the total force acting on the body? Anybody, any lady to help us before there is one hand up. I just want to be sure. Okay, maybe Carol, if two forces are acting along the same direction.
That is, you add them.
Good. So here, the resultant force will be the addition of all of them. So F1 plus F2, meaning that for diagram 1, the resultant force will be 250 plus 100, which will total 350 Newton. So this will be the resultant force. So by the theory, if there's the largest resultant force, then automatically you must have the largest acceleration. From Newton's law, whether resultant, unbalance, or total force is equal to mass times the acceleration. Therefore, acceleration will be 350 divided by 50, and that is 7.0 meter per second squared. Let's then find the acceleration of all the other forces. What will be the net force in the second diagram? What will be the net force in the second diagram? What will be the net force in the second diagram? Jeda,
150 Newton.
Okay, so why 150?
Since the forces are going in opposite directions, you subtract.
Oh, good. So when two forces are acting oppositely to one another, the net force is determined by subtracting the smaller force from the larger force. So the resultant, the net force or unbalance will be F2 minus F1. So 250 minus 100, giving us 150 Newton. The acceleration produced will be 150 divided by 50. And this would be 3 meters per second squared. How do we determine the net force in the third diagram? Ladies, I want to hear from you. Sharon, are you here? Sharon.
Yes, sir.
Sharon, how do we determine the net force when two forces are perpendicularly to one another?
I think you use pen, pen, Pythagoras theorem.
Okay, thank you. So Sharon is suggesting we use my good old friend Pythagoras' theorem. Sharon, state it for us. Pythagoras theorem. State Pythagoras theorem for us. Not in formula, but in words. Okay, somebody else should also help. Mavis, Carol.
The Pythagoras theorem states that the square of the hypotenuse is equal to the square of the opposite, is equal to the sum of the opposite square.
For a circle, is it applied to circles, Carol?
No, please.
Then you must state it well. Come again. Okay, let somebody else also come in. Jonathan Mensah.
In a rectangle triangle,
Uh-huh.
the square of the longer side is equal to the square of the sum of the other two sides.
Okay. Okay, so if you have a right angle triangle, okay, the square of the longest side, which is the hypotenuse, is equal to the sum of the squares of the two other sides of the right angle triangle. So we wouldn't waste time. F resultant squared will be equal to F1 squared plus F2 squared. So thank you, Carol. Thank you, Sharon. And thank you, Jonathan, for putting a Pythagoras theorem in shape for us. So since we have F1, 100 squared plus 250 squared. 100 squared is 10 to the power 4, 10,000. What is 250 squared? What is 250 squared?
62,500.
62,500. So 62,500. Okay, sum those values for me. 10,000 plus 62,500. Yes, I'm waiting for you. Yes, go ahead. If you are ready, just go ahead. 72,500, is that correct?
Yes, sir.
Yes, sir.
Yes.
All right. Therefore, FR, which is the resultant, will be equal to the square root of 72,500 plus what is the square root of this value? Square root of 72,500. Please go ahead.
269.25.
So the resultant force FR is equal to 269 approximately. Let's approximate it to the nearest whole number. Sean, your hand is up. Okay. Therefore, help me calculate the acceleration. Help me calculate the acceleration. And here I'll call on Aseda to give me an answer. What will be the value of the acceleration here? Aseda, are you ready? Aseda is not ready. Can somebody call it out? Yes, Adewa.
So it's going to be 269 out of 50, which is 5.4 meter per second squared.
5.4 meter per second squared. So when you look at the first, second, and the third scenario, the first one is giving us the greatest acceleration. Then the second one is also giving us the least or the minimum acceleration. Okay, so note that when two forces act along the same direction, the resultant force is the largest among all other directions. And when they are oppositely directed, the resultant force is minimal among all other directions. What do you think will be the direction of the greatest acceleration? What will be the direction of the greatest acceleration? Francis?
Sir, to move to the right.
Why?
Because of, I don't know how to say it.
Oh, what will be the direction of the greatest acceleration? Yes, another hand is Pascaline.
It will move to the right-hand side because the direction is applied. The force applied is to the right-hand side.
See, yes, all the forces act along one direction. So it will move to the direction of the forces. So in the second scenario, we have the minimum acceleration. What will be the direction of the minimum acceleration? What will be the direction of the minimum acceleration? Carol?
So please to move to the right
Why?
because more force is applied on the right and the left.
Good. Acceleration always follows the direction of the larger force. Here we have two forces. So the acceleration always follows the direction of the larger force. Okay. In the third scenario, we need to get the direction of the resultant force. And because they are perpendicular, the direction of the resultant force will be along the diagonal here. That's drawn in pink. And that would also be the direction of the acceleration. We'll come to vectors. So this is it. This is a typical application of whatever we've done. Please, if you have any question, quickly ask before we continue. Is there any question? Okay. Silence means okay. Rebecca.
Sir, please, can you go over what you said about the direction? It's not clear to me.
So, acceleration is directly proportional to the resultant force, whether applied force, resultant force, net force, or unbalanced force is a force. So when you get the direction of the resultant force, that would also be the direction of the acceleration. Okay, when you, Viveka, when you push, when your brother and yourself put your hands together and you push against one another, if the force you apply is greater than your brother, you move along your brother, okay, and the movement is the acceleration of your brother. Your brother would accelerate in the direction of your force. So bodies always accelerate in the direction of the larger force. In the first case, because the two forces had a common direction, they were all due east or to the right. So the acceleration would also have a direction along the same path. Vivek, are you okay?
Yes, sir.
In the second case, the larger force is a 250 or F2. Bodies always accelerate in the direction of the larger force. So yes, when you subtract, the net force will be 150, but the acceleration will take the direction of the larger force involved. So it will also act due right. Then in the third case, you need to resolve them and get the direction of the resultant. The resultant force, F resultant, will act along the diagonal. So because the resultant force has a direction along the diagonal, the acceleration would also follow this same direction along the diagonal. That's what I said. Are you okay now?
Yes, sir. Thank you, sir.
Welcome. Let's look at an inclined plane. Inclined plane. Class, can somebody tell me what an inclined plane is? What is it? What is an inclined plane? Anybody to share what he or she knows with us? Yes, Judah Kumsen.
Sir, please, it's a simple machine.
It's a simple machine.
Sir, please, that's what I wanted to say.
Okay. Yes, it's a simple machine. All right. Okay, I have. Okay, Viveka, come in. Viveka, go ahead. Your hand is up.
Sir, it is usually like a flat surface that is tilted to an angle, and then you can use it to push objects up and down.
Okay, thank you. Have we exhausted individual views? Inshira, I saw your hand being raised. Carol,
it is a simple,
the way it's a simple
machine that connects a higher surface to a lower surface.
Okay, I get you. All right, so it's a simple machine. So we can represent an inclined plane using a rigid board leaning against a wall or a track. So if you have a very rigid board or bar leaning against a track, let's use a track. Maybe a truck for loading goods. So this is the ground. The tire of the truck. In fact, we are not here to draw tracks. Okay, but something just to represent something. Yes, what a truck. Yes. So if this is the lower end and this is the upper end, okay, the inclined plane, this is the length of the plane from the lower end to the upper end. This is the length of the plane. A. It is inclined at an angle to the ground. This is the ground. So the angle of tilt is this, theta. So when you happen to have goods here, you can use the inclined plane to load and also offload goods. I have witnessed an electricity company of Ghana using inclined planes to offload their poles, wooden poles. Okay, after parking it within a truck, when they are unpacking, they just create an inclined plane, and then the workers push the poles along the plane, and it gets offloaded instead of they gradually removing them one by one. No, they use the inclined plane. And market women also use the inclined plane to load their foodstuffs and some other items in a truck. So it's a simple machine which can be used to load and offload, materials. Any question? So that is what we are actually going to investigate. What is it about the inclined plane? Okay, so we have a body. Let's take this to be the inclined plane. Of course, this is the ground. We have a body or a particle rolling on an inclined plane. Let me tilt it a little bit. Okay, it's okay. So this is the height of the plane. This is the length. OA is the length. It makes an angle theta to the ground. And the angle is known as the angle of the plane. You know, on an inclined plane, because it is not flat, it is tilted at an angle. Whenever you put something on an inclined plane, you can even use your book, tilt it at an angle. When you put your pen on the book, it is always rolling down. So objects hardly stay stationary on an inclined plane. It is when you put an object on an inclined plane, it is always rolling down the plane. It's always rolling down the plane. Today we would investigate to know what is responsible for this. Why object placed on an inclined plane always rolls down the plane. So once this is an object, we have its weight, which is always perpendicular to the ground. So we have this vector representing the weight of the object on the plane, W. And don't forget, weight is mass times gravity. Okay. So this is one of the forces acting on the inclined plane. There is another force acting on the plane, and that is the normal reaction. You see, the normal reactional forces, no matter the surface, must always be perpendicular. That is why we call it as normal. Normal means perpendicular. So we have this reactional force R, which is perpendicular to the inclined plane. Okay, so you see, when we're looking at a body on the flat on the ground, we saw that if this is the weight, there is also an opposite force, which is reactional force. But because the body lies flat on the surface, the reactional force in this case is equal to the weight.
Mass
times acceleration due to gravity. So when the body lies flat on a surface, the reactional force is always perpendicular to the weight. And this, we got this from Newton's third law, that forces move in pairs. Now, when the body lies on a surface that is tilted, the reactional force this time isn't directly perpendicular or equal to, the reactional force is not really equal to the weight. And this is because of the angle of tilt. Because it is tilted at an angle, the reactional force is not equal to the weight mg. Please, class, are you there? So here, this is the reactional force, which must always be perpendicular to the surface. So R is perpendicular to the surface OA. Perpendicular to the surface OA. So reactional forces are always perpendicular. That is why we call them as normal reaction. So if this is the case, let us extend the reactional force downwards. When you extend this reactional force vector, this line is still equal to that. It's the same as the reactional force. Okay. So this is a line extending the reactional force downwards. Then this is, look at something. We want to determine the angle between the reactional force and the weight. This angle. This angle here. Now, when we do that, you see we have created, let's label this point OA. Let's indicate this point to be maybe B. B is this point. Then indicate this point here. And then this point here. This is, the weight is perpendicular to the ground. So 90. We want to determine the value of this angle X. Okay. Class, if the reactional force makes an angle of 90 to OA, what will be the angle between the same reactional force and this side and the plane? What will be the angle here?
90 degrees. 90 degrees.
That's also 90.
90.
Okay. We want to determine x, but we have, let me label this point as DE. So when you considering triangle OBE, OB, this point E, if this is 90, the weight is always perpendicular to the ground. So this is also 90. If this interior angle of the triangle is theta, and this is 90, class, what will be this angle? Let me use a different color so you can see it well. There's the angle I'm talking about. If this is theta, this is 90, what will be this angle? Can anybody help? Francis?
Minus theta.
90 minus theta. Okay.
Yeah.
Or, you see, considering triangle OBE, sum of angles in a triangle is 180. So theta plus 90 plus this unknown angle, let's represent it by y, must be equal to 180. So when we make y the subject, we have 180 minus 90 minus theta. Class, are we okay? Class, are we okay here?
Yes, sir.
All right, so we have Sharon. Are you following? Inshira, Stephanie, Maxwell, Kojo. All right, so 180 minus 90 is 90 minus theta. So this angle y is equal to 90 minus theta. Now, what do you think will be this angle 2? What will be the angle between the plane and this? The inclined plane and the reaction. The angle colored in green. What will be the total angle there? Hubert?
It will be 90 degrees.
90 degrees, because this is 90. This is also 90. So from the same plane to the standard line of the reaction, it will also be 90. Okay. So we have two angles in there. We have y and we have x. So we can say that y plus x is equal to what? Class is equal to what?
90.
Let me hear that from your houses.
90 degrees.
90
degrees. Good.
90 degrees.
Good. So the two would sum up to be 90. Meanwhile, we have one of them, y. Y is equal to 90 minus theta. So substitute 90 minus theta in place of y, and then help me get the value of x. Help me determine or calculate the value of x. Yes.
It's theta.
That's theta. I want the rest of you to also try. So simplify, y is 90 minus theta. Substitute that into this equation. Janice.
Sir, please, theta.
So you have x to be equal to theta. I'll go over this. What this means is that, let me redraw an inclined plane for you to see something well. If you have an inclined plane, tilted by maybe 30, this is a body. This is the weight of the body, W. The reactional force, which is always perpendicular to the surface, is here, R. When you extend the reaction, the angle between the weight and then the reactional force extended in the opposite direction must also always be equal to the angle of tilt. So if the inclined plane is tilted by an angle 30, the angle between weight and then the reaction must also be 30. That is what it means. So we tilted this by, let's even prove it. Let's draw again and then prove it. We are saying let the angle be 30. So assuming SN, Ella, Manuela, I can hear you.
Sir, please, can you repeat what you said again?
I'm going over. I'm using
Sir.
angle. Okay? I'm going over, don't worry.
Sir, please, can you repeat what you said again?
SN, don't worry, I'm going over, so you get it. So the weight is W. The normal reaction is expected to be perpendicular to the inclined plane. So that is here. R. If we extend the normal reaction, R is also here. The same line. So we just want to confirm what this angle would also be. If this is 30, we just want to prove if this will also be 30 degree. Class, are you with me?
Yes, sir.
You just want to confirm. So assuming this is X, what will be the value of X? Okay. The normal reaction must always be perpendicular to the surface, whether it is flat or tilted. So this must be 90. It means that this must also be 90. It also means that if I draw an angle from here to the reaction, this must also be 90. Assuming this O point this is B, and this is C. The weight must always be perpendicular to the ground. And there's the ground. Okay, there's the ground. So this is 90. So if this angle is A1, we know that A plus X must be 90. A plus X must sum up to be 90 degrees. So if this is 90 and this is 30, what will be the value of A? If the angle at C is 90, angle at O is 30, what will be the angle A? Yes, anybody? Hubert?
60 degrees.
Good. So because for a triangle, sum of angles in it must be equal to 180. Or if this is 90, it means A and 30 must also sum up to be 90, so that when we add that to 90, it will give us 180. So if this is 30, this must also be 60. So A is equal to 60. 30 plus A must be equal to 90. So that A will be equal to 60 degrees. If A is 60, we know A plus X must also give us an angle of 90. So X would be equal to 90 minus A, and that is 90 minus 60, which is 30 degrees. Sean, your hand is up. What is the reason?
I was going to answer the question.
Okay. All right. So the theory is that for an inclined plane, the angle of tilt is always equal to the angle between the weight and the normal reaction. Okay. That's the first important thing as disciples of physics you must understand on an inclined plane. So if you have a body placed on an inclined plane, the angle between the weight of the plane, in fact, let me use straight lines. This is a normal reaction. So there is a normal reaction. This is the weight W, then extended. If it is tilted through an angle theta, the angle between the weight and then the normal reaction must also be theta. Class, are we okay here?
Yes, sir.
Yes, please.
Okay. Now, we see the weight vector or the weight of the object tilting through an angle theta. We have done trigonometry a little bit. So this is what I'm talking about. We have the weight acting in this manner. Then the reaction is also here. The weight makes an angle theta to this line. If I want you to measure, supposing we have a protractor and I want you to help me measure this angle, how would you do it? Class, I want you to help me measure this angle theta using a protractor. Practically, how would you do it? Can anybody help? Sharon. Sharon, are you there?
Yes, sir.
You have a protractor. I want you to help me measure this angle theta. How would you do it practically?
Sir.
Hello, sir.
Protractor.
How would you measure this angle? Zion, come in to help. Zion. Okay, Janice wants to bail you out. Janice, go ahead. Janice, I'm listening.
Please, I think we should place the baseline of the protractor on W.
So, you mean the baseline must be placed here? It must rather be this. We put the 90 here, isn't it? And then the 0 line on, let's take this to be O. Then A. The 90 point is placed here, and then the 0 line, 0, 0 is put on OA, isn't it, class?
Yes, sir.
Yes, I understand there are so many ways of doing that, but one of it is that we'll put the 0 line here, and then the 90 point here. So we read this, okay, in that clockwise direction, isn't it? Class, are you with me?
Yes.
Yes.
Placing the 0 line here makes this the adjacent. The adjacent.
Yeah.
Jadida, mute yourself. The adjacent to the angle. Now, once you have the adjacent, a line perpendicular from the adjacent gives us the opposite. So this line, once we have located the adjacent, a line perpendicular from the adjacent will be the opposite to the angle. Then automatically, the weight line becomes the hypotenuse. So this is the opposite, adjacent, opposite, and the hypotenuse. Adjacent is always perpendicularly to the opposite, right? So we have a right angle triangle. If we want the opposite, once we have the angle and the hypotenuse, how do we determine the opposite? You have the hypotenuse, you have the angle of inclination. How do we determine the opposite? Anybody? How do we determine the opposite to the hypotenuse or to the angle theta? Oh, trigonometry. Okay, because of time's sake, let me. So if we have the interior angle and then the hypotenuse, yes, Carol.
So please you use the tangent.
Carol, listen, we have the interior angle and the hypotenuse. Tangent is about opposite and adjacent. Here we have the hypotenuse and the interior angle. Do you get it? And we are looking for the opposite. So when you use, okay, you bet.
We use CAH. Because
you see, no, we are looking for the opposite. When we have the hypotenuse and the angle, we have to use sine. Sine of the angle, sine theta. And what is sine? Sine is so, isn't it?
Yes, sir.
So is the ratio of the opposite side to the what? The opposite side to the hypotenuse, isn't it?
Yes.
Okay,
Please.
so sine theta would be equal to the opposite, which is colored in red, divided by the hypotenuse, which is the weight. Hypotenuse is the weight. Therefore, the opposite side is equal to W times sine theta. And what is W? W is mg. So mass on the inclined plane times gravity times sine of theta. So that will be this part, the opposite side. And if we want the adjacent is this line OA. Okay, how do we determine the adjacent? How do we determine the adjacent? Of course, we must use CAH, which is cosine. Cos is equal to adjacent over hypotenuse. So when we take cosine of the angle theta, we have the adjacent which we are looking for, colored in blue. So adjacent divided by the hypotenuse, which is W. If we make adjacent the subject, we have W times cos theta. Since weight is mg, mg is equal to cos of theta. Let's bring this back to the inclined plane. What it means is that on an inclined plane, when the weight tilts at an angle, we have a component of the weight which is perpendicular to the adjacent. So this component is the opposite. The opposite is equal to mg sine theta. Then we have the adjacent. The adjacent is mg cos theta. Class, are you with me?
Yes, sir.
If you have any question, ask before we continue. Justice.
Sir, please, I don't understand the cosine. How you got the W and the sign to the W?
You see, W is the weight of the object on the inclined plane. The weight.
So the weight is the hypotenuse.
The weight of the object on the inclined plane. You see this rectangular thing I've drawn is the object. So the weight of this object on the inclined plane is W.
Okay.
Are you okay?
Yes, sir. So it's moving fast. You're moving fast. That's why.
Come again.
So you were moving fast at that place. So I didn't get it.
Oh, okay. So W is the weight. R is the reactional force produced by, the object. You know, forces move in pairs. So if there's actional force, which is the weight, there must be a reactional force by Newton's third law. Okay. So on an inclined plane, we always have a component of the weight. Okay. The mg cos theta, this is always perpendicular to the inclined plane. The angle between the inclined plane OA and the adjacent, we can say that the adjacent is perpendicular to the inclined plane. So please note that the mg cos theta component is always perpendicular to the inclined plane. Mg on an inclined plane, mg cos theta, component of the weight, W, of the weight, is perpendicular to the inclined plane, is perpendicular to the inclined plane, to the plane. And then the mg sine theta is parallel to the inclined plane. Mg sine theta is parallel to the inclined plane. Okay. Please, by perpendicular, we are talking of the OA is the inclined plane, and the angle between OA and the adjacent is 90. So the adjacent is mg cos theta. So mg cos theta is always perpendicular to the inclined plane. Then the opposite, which is also mg sine theta. Hold on a minute, I'm coming. Okay. This is the opposite. The opposite, which is mg sine theta, is also parallel to the inclined plane. Now you see, this is the opposite. It is here. Vectors can be equal no matter where they are, if they are equal and parallel. I know because you haven't done vectors, you may have your own issues with it, but we are here to treat vectors, so I'll talk about it again. We can bring the opposite along the inclined plane here because they are parallel. So we can also choose to bring the opposite component here along the inclined plane, because what is here can be equal vector. So instead of it being here, we can bring it here on condition that they have the same direction, magnitude, and parallel to one another. Justice.
Yes, I don't understand that.
You see, we have what we call equal vectors. Vectors are equal no matter what they are, if they have a certain features. The features is that they must have the same direction. That is why the opposite has direction downwards, and I'm not changing the direction of what I've brought here, because what is here and what is here must have the same direction, and they must have the same magnitude to be equal. Okay, so just as I know, because you haven't done vectors, it will be some way to you, but we'll come there. Okay, so all that I'm doing is that I want to bring mg sine theta, which is the opposite component of the weight, along the body or along the inclined plane on OA. Okay, so mg sine theta, mg sine theta. And so you can see that mg sine theta is parallel to OA. Okay, then mg cos theta is also perpendicular to OA. All right.
Yes, sir.
Now, if you look at the forces acting on the rectangle, we have the downward component mg sine theta balanced by the reactional force.
Oh.
I'm coming. So we have R. Look at this force acting down here. It is balanced by R. So R, we can say, is equal to mg cos theta. Now, please note that on an inclined plane, the reactional force is given by this. On an inclined plane, the reactional force is equal to mg cos theta. However, if the body lies flat on the surface, the reactional force is always equal to mg, which is the weight of the object. So please note this difference. When the body is flat on the ground, the reactional force is equal to mg. When the body is tilted at an angle, the reactional force is mg cos theta. Okay, remember that when we are calculating for the friction was seen to be equal to coefficient of static friction times the normal reaction. And so he said friction is equal to mu times mg. Class, do you remember?
Rama.
Yes,
Class,
sir.
good. If the body is on an inclined plane, the friction would be equal to mu times R, and R on an inclined plane is this. So on an inclined plane, friction will be given by mg cos mu times mg cos theta. Please mute yourself, Desmond. So on an inclined plane, this is the value of friction. So please note this difference. This is on a flat surface, but on an inclined plane, because normal reaction is equal to this, friction would also be equal to this. Sean.
Yes,
Or
sir.
just ask your question.
That. Good afternoon.
Hey, Desmond.
Pacho, my phone na what's also doing like?
Justice.
What?
Desmond. What you are saying is open to us all. All right. So please note that yes, on vertical equilibrium, the normal reaction is balanced by mg cos theta. So R is equal to mg cos theta. Justice. Justice, if you...
I think he was trying to ask for permission from you.
Okay. I think he sent me a message. So I thought he was calling somebody to inform him. All right. So R is equal to mg cos theta 1, meaning vertically there is a balance. This reaction is balanced by mg cos theta. Horizontally, we see mg sin theta. What is its component at the other end or the opposite end? Do we have any force balancing mg cos sin theta?
No, sir.
Class, do we see any force balancing mg sin theta?
No, sir.
No. So horizontally, mg sin theta is unbalanced. Because of this unbalanced force on the inclined plane, that is why bodies always accelerate down an inclined plane. So because of the unbalanced force, mg sin theta, that is why bodies accelerate down an inclined plane. When we started, I said that on an inclined plane, when you place an object, it will always fall down the plane. So if you tilt your book and then place your pen will slide or accelerate down the plane. The acceleration of your pen down the plane is as a result of mg sin theta. The mg sin theta is always acting down the plane. This is the reason why when you place an object on an inclined plane, it is always falling down the plane. It is because of the unbalanced force mg sin theta. Class, ask your question if you have one. Justice.
Yeah. So please, will you be giving us any work on this? Maybe to try.
We'll be trying well. Yes, I will. Because I know if I don't do that, you'll not understand. That's why. Okay. So let's put things you must understand together. 1. Yes. Pascaline.
Sir, please, my network got disconnected, so I don't know what you are teaching.
Hey, Pascaline.
Sir.
Okay, let's put whatever we've done together. My problem is that I don't know where exactly you got lost, so as to explain.
So what if written a mg sin theta equals to unbalanced?
Okay, let me go over that part. So we just saw that on an inclined plane, there is always two forces or two components of the weight. One component of the weight is always perpendicular to the inclined plane. Just mute yourself. I'm coming. Let me clear this part. So when we resolved, we got two components of the weight W. One component is perpendicular to the inclined plane, and that is mg cos theta. Another component is the opposite side to the weight, which is here. The other component is this component, which is parallel to the inclined plane. This is given as mg sine theta. Mg cos theta is perpendicular to the inclined plane, meaning it makes an angle of 90. Mg sine theta is parallel to the inclined plane, meaning it makes an angle of 0 to the inclined plane OA. Okay, Pascaline and those of you who lost out somewhere, are you okay?
Yes, sir.
Now, if we look at the total forces or upward and downward forces on the body on the inclined plane, we see that vertically, the normal reaction R is balanced by the downward force mg cos theta. And because of this balance, no movement would occur vertically. There will be zero acceleration vertically because there is a balance. Horizontally along the plane, OE, mg sine theta has no balancer. There's no component here which balances mg sine theta. So we say that mg sine theta is unbalanced. It's not balanced. And Newton is saying that if there is a force in whichever direction, it causes acceleration. So the unbalanced force mg sine theta is responsible for the acceleration of bodies down an inclined plane. So when you tilt a bench or a table and then you place a book, it will always roll down the bench, isn't it, class?
Yes, please.
It will roll down the plane because of the unbalanced force mg sine theta. This is always acting down an inclined plane. So when you put an object, that is why if traders are offloading their goods from a truck, all that they need to do is just have some people to stand down here, and then they push whatever they are offloading. The moment it touches the plane, the body will naturally roll down the inclined plane, because on an inclined plane, there's always an unbalanced force, mg sine theta, which is responsible for moving objects down the plane. If you are pushing, if the object is being put in a trap, then you must apply a force which is greater than mg sine theta in order to move it. Okay, so things you must understand on an inclined plane is that, one, the angle of tilt. So one, on an inclined plane, so one, angle of tilt is always equal to the angle between the weight mg and the normal reaction. So if the angle is 30, the angle between the weight and the normal reaction would also be 30. That's one. Then two, a perpendicular force of mg cos theta, or let me put it in a different way. There is mg cos theta component. Mg cos theta component is always perpendicular to the inclined plane. Mg cos theta component of the weight of the object. Component of W is always perpendicular to the inclined plane. Then three, mg sine theta component is the unbalanced force responsible for accelerating objects down the plane. Three key things you must understand on an inclined plane. So when you are asked what force is responsible for accelerating bodies down an inclined plane, what will be your answer? What force is responsible for accelerating bodies down an inclined plane? Class, how would you answer this?
Unbalanced
Carol,
force.
is there what?
Unbalanced force.
The unbalanced force, which specifically is the
mg
sine theta.
Exactly. Mg sine theta. So let me create a simple question for you. Just create a simple question. At least for you to have a feel of how it is used to solve problems. We have an inclined plane. The angle of tilt or angle of inclination, we are told this is 25 degrees. A body of mass 100 kilogram rolls down the plane. 1. Calculate the component of the weight of the object's weight which is perpendicular to the inclined plane, which is perpendicular to the Judah Bolabeng to the inclined plane. 2. The unbalanced force,
Who is calling me?
Force.
Yeah.
In fact, let me mute all, okay? Else you tell me everything. The unbalanced force down the inclined plane. And 3, the normal reaction reactional force on the plane. And last question, the length of the plane. The length of the plane if the height is 2 meters. Take G to be 10. Take G to be 10 meters per second squared. Can we try? So last question of the day. We are told the height of the plane is 2 meters. So just 5 minutes, attempt it, okay? Binta.
Sir, please, 1. What word comes after object? The component of the object.
Weight, which is perpendicular, weight.
Hey,
Judah. Judah Kumsen.
Yes,
sir. Weight or weight?
I'm coming. It's weight. W. Judah, mute yourself, okay? It's weight. W-E-I-G-H-T. So the component of the weight, object's weight which is perpendicular to the inclined plane. What's your answer? 1. What's the answer? Oh,
423.
Speak up, Enoch.
So please, I said 423.
Okay, so of course, the component of the weight which is perpendicular to the plane is mg cos theta. So the mass is 100, gravity is 10, cos of 25. Okay, so point cos 25, cos 25. Please, when you are doing this, make sure your calculator's angular measurement is in degree. So this times 1000. So 9. Enoch, what's your answer?
Sir, please, it's wrong. I rather use sine theta.
You see, oh, so you must have approximately 906. So the component of the weight which is perpendicular to the plane will be 906. Class, are we getting it right? Class, are we getting it?
Yes, please.
Yes, sir.
The unbalanced force acting down the inclined plane. On an inclined plane, we always have an unbalanced force of mg sine theta acting down the plane. So the unbalanced force which would accelerate the object down the plane will be 100 times 10 times sine of 25 degree. So sine 25, Isabella.
Yes, sir.
Mm-hmm.
The answer for the number 2.
Yes, go ahead.
Sir, please, I got 422.6
Absolutely.
newtons.
So approximately 423. So if you leave it at 422.6, you are not wrong. Okay. So that unbalanced force which will roll the object down the plane must be 423. The normal reaction. Okay.
I can finally.
Pardon, Isabella. Okay, the normal reaction. On an inclined plane, normal reaction is always equal to the component of the weight which is perpendicular to the plane. So R must be equal to mg cos theta. So if mg cos theta is equal to 906, then it means that the normal reaction must also be equal to 906 Newton. Please, did you get that?
Yes.
Yes, sir.
Only 2 responses out
Yes,
of
sir.
more than 70. Okay. Then the fourth part, the length of the plane. We are looking for this. The whole length of the inclined plane. Okay. Now, what we have here is a right angle triangle. So you can use that to determine, once you have the interior angle, the angle of inclination, and then the height of the plane, you can use sine 25 degree is equal to the opposite, which is 2, divided by the hypotenuse, which is the length of the plane L. L therefore is equal to 2 divided by sine of 25 degrees. So please calculate that for me. 2 divided by sine of 25 degrees. Leave your answer in 1 dp. Anybody? Leave your answer in 1 dp. Hubert.
Sir, please, 4.7.
Manuela Isian. Joel Apia, did you get the same thing?
Sir, please, yes.
So that's the length of the inclined plane. So simply, this is a real question on an inclined plane. Okay, so we'll look at other dimensions of an inclined plane next week. Then we solve more questions to strengthen whatever we've learned. Carol?
So please, there are 3 important things we must know about inclined plane. I didn't finish copying it.
Okay. So back to you. Inshiraminta.
Sir, please, will this video be posted on the group?
Yes, I will.
Okay, sir.
All right. So class, this is where, but please, you still have the chance to complete work on the assignment and then send it to me. I'm giving you enough time. Tomorrow, the deadline is tomorrow. So I want to see more than 80 of you submitting. That is why I've extended the time. All right. So may the good Lord be with you. Take care of yourselves and then see you next week. But please do not forget to subscribe to the channel. I want subscription, share the videos and all that so as to grow the channel. Okay. Bye-bye. See you next week.
Bye.
All right. Carol, are you done? Carol? The blackboard cleaners have started to clean. Oh. So, bye-bye. Look at yourselves. Instead of you to just go away in peace, you are writing on the board. Bye-bye.